Hi, I'm Bob Ward from Microsoft, an architect on the Azure data team. First, I want to give a big shout out to all the folks involved and who normally attend and organize the SQL Bits conference. It is one of my most favorite events in the world to go to and be a part of. And I'm sorry that we will not be able to be together this year in person. I hope you're doing well wherever you are in the world. However, today I'd like to talk a little SQL 19, so hopefully you can sit back and enjoy learning more about SQL 19, the modern data platform. SQL Server 2019 is called the modern data platform because it's not just about the database engine anymore. Now, before we get started in today's presentation, there's a couple of resources I think you'd want to see. Number one, you can get the complete slide deck that you see here today for SQL Server 2019 at the first resource here, aka.ms, bobwardms, plus a bunch of other decks and presentations I've done on SQL Server. And then the second link is where our workshops exist, aka.ms SQL Workshops. There you'll find a complete workshop on SQL Server 2019, including all the demonstrations I'm going to show you today and more. Now, when I first started presenting SQL Server 2019, it was just a bunch of features when we kind of started this journey and talking about it. And so what we realized is that, customers want to know how SQL Server 2019 provides solutions to the challenges they meet today. So it's not just about a feature, it's about a real solution that matters to you, whether it's trying to get rid of those ETL programs that have been expensive to you, or ensuring that you can get great performance from SQL Server and faster performance with no application changes. Now, certainly you've looked at things like containers, and it's just not a fad, it's actually something that's real. So we've invested in SQL Server containers, you're going to find more about that. And machine learning is not just a buzzword. It is actually a new paradigm of building applications, and SQL Server is certainly a big part of that. Now, as I presented SQL Server 2019, I've noticed that I talk to customers about features like query store, always encrypted, and they look at me a little bit funny because they're used to using older versions of SQL Server that doesn't include that functionality. And it dawned on me that SQL Server 2019 includes great capabilities and functionality from SQL Server 2016 and 17 the customers just not were aware of. But that's our fault, not yours. And so take a look at this slide here to show you that when you get SQL Server 2019, you get all this functionality that comes with it. Now, in today's presentation, we're going to focus more on what's new for SQL 19 to meet those challenges. But just keep in mind and make sure you know that you get query store, automatic plan correction, JSON support, temporal tables, graph databases, all these kind of type functionality is part of SQL 19. Now, if you're going to look at SQL 19 overall and its capabilities and solutions that meet these challenges, I have found it's very helpful to show this slide. I call this my camera slide because when people see this when I present in person, they want to take a picture of it with their camera. And it all starts with data virtualization. The idea being is that I could join data across all these icons you see right here without moving data. And the fact that we've built an entire platform around big data technology called big data clusters. Now, moving left to right, it is about platforms. Did you know that SQL Server runs on every one of these icons you see listed right here in what we call a compatibility mode? And it's just a special mode of SQL Server. The fact is that the SQL Server engine is the same across all these technologies. You can take a backup of a database on any one of these icons and restore it to any one of these icons. I'm not even sure there's a data platform in the industry that can say that today. And then finally, machine learning and extensibility have been part of our journey starting with SQL 16 with R and Python in SQL 17. And we've extended that with Java now in SQL 19. And if people look at this particular diagram right here, they're wondering, can I really run R or Python on my SQL Server? It doesn't feel very secure to me. We'll talk about how the architecture lends itself to that. As we went to the journey of SQL 19 and my colleague Travis Wright saw this diagram, he said, Bob, this isn't your grandpa's SQL Server anymore. Well, what did he mean by that? What he meant is that it's not a database engine anymore. It is an extension of SQL Server integrated with various technologies like big data, running on Linux containers, or even using things like Java, Python, and R programming. Now, my colleague Pedro Lopes says, Bobby, it is your grandpa's SQL Server because we continue to enhance the power of the database engine. And if you start with performance, it's all about intelligent performance. So it's not just about becoming fast, it's keeping you fast. It's about making you fast with no application changes. And we're going to take a look at that a little bit today. And then when it deals with security, you want to understand, you want to make sure that you have all the tools and features in SQL Server to secure your assets and be compliant. And one of the things we'll talk about a little bit is a new functionality called data classification, which kind of help with some of those scenarios, kind of like GDPR. And finally, in the area of availability, you're going to love the amazing story I'm going to talk to you today about accelerated database recovery. So if you look down to the bottom down here, you've got performance, security, and availability, not necessarily in that order, kind of the meat and potatoes of SQL Server. So who's right? Is it Travis or Pedro? It turns out they're both right. This is why SQL Server 2019 can be considered a modern data platform to integrate with technologies like big data, run on containers and Linux, run on any kind of platform you need, integrate things like machine learning and Java, but then an enhanced database engine that powers everything you need, again, to meet the challenges that we talked about originally when we started doing this presentation. Now, one of the first challenges we wanted to solve with SQL 19 was something called data virtualization. The ability for you to query data without moving the data, kind of reduce the need for ETL jobs as much as possible. Because what we realized talking to customers is they have lots of different data sources, but sometimes they cannot move that data into SQL Server as much as we want them to. So why not provide an ability to go after these data sources through T-SQL, through a concept called an external table, query data where it lives, push queries down to these sources in an intelligent way, and then join that data with local SQL Server data. We introduced this concept in SQL 16 called Polybase, and we've just expanded on that. Not just now being able to query Hadoop data, but querying Oracle, Teradata, SQL Server, MongoDB. And imagine in a world where you didn't install the client drivers on the SQL Server to get access to that. Everything just built in for your needs. And then extend that with ODBC drivers of your choice that you would install for data sources like DB2 or HANA or even Excel files. A wide variety of sources, provided you have a driver. And imagine if this entire solution was secure, using the power of security over external tables, and scalable. We can use multiple Polybase servers called scale-out groups to get data in a very scalable way. What you see here is an example of doing that with SQL 19. Imagine your SQL Server is the data hub of your data virtualization environment, and you have data sources and all the things listed in this diagram. You could define external data sources and external tables in your main SQL Server that point to all of this. Your users don't have to log in directly to these data sources. You control security of that. Your users don't need to know the language of all those data sources because you're going to use T-SQL to query external tables, which is metadata stored in SQL Server, not the data. And then we'll be intelligent to push queries down to any of these sources. And imagine if you could join everything on this screen right here using SQL Server in an intelligent way, using local statistics, using scalability, using the power of Polybase with SQL Server. This is all possible and is the new world of data virtualization. Now, we decided as part of doing data virtualization, we needed a full solution for analytics. We call that SQL Server Big Data Clusters. Using the power of Kubernetes, we're going to build a series of nodes in a one-stop deployment fashion that is going to allow you to access HDFS data through Polybase. But in this particular case, we could deploy HDFS for you, or you could bring your own through HDFS tiering. We're going to deploy Spark locally, so you could actually have natural Spark interfaces to ingest data or run Spark jobs against this data. And we're still going to give you that power of Polybase with external sources like Oracle or Teradata. You can join all of this together through a big data cluster through the SQL Server master instance. You can actually take results from your ad hoc queries in this environment and store them in a data mart called a data pool, where you're still going to use the power of Polybase, but we're going to abstract you behind the scenes and going to shard out your data and use column store to make those weekly reporting type scenarios very, very fast. We're going to include availability groups. We're going to include Active Directory authentication on top of this. And to give you an end-to-end machine learning solution, imagine if you ingested your data using a big data cluster in this model through all these different data sources. You prepare and train your model using the system, and you're going to save this and expose it as an application through a REST endpoint. In essence, a complete end-to-end machine learning solution using big data clusters. And Balzano is a very good example of a customer that's done exactly that right out of the gate with SQL Server Big Data Clusters, which is included as part of SQL Server 2019. Let's take a second to take a look at a demonstration of the power of Polybase in SQL Server 2019 with data virtualization. Now, what you see in front of you is Azure Data Studio. You may have seen this tool announced before. Azure Data Studio being a cross-platform open source tool for using SQL Server and other resources like Azure. And in front of you is what's called a T-SQL notebook. I love these notebook concepts because not only does it have a combination of Markdown code and T-SQL code to run, but the output is saved in the file. So I've got an example of Polybase with SQL 19 going after an Azure SQL database data source using this external table concept I talked about. Let's kind of look at that a little bit more in detail here. So in my notebook, and by the way, I mentioned about SQL 19 workshops, SQL workshops. All of these notebooks you see here I'm going to show you are available by going to ak.ms SQL workshops in the SQL 19 workshop itself. They're all saved for you to look at and then go use on your own. So in step 0, I'm just creating my remote database and table in Azure, and I'm showing you the schema, what that looks like. And then as you scroll down here, one of the first things you're going to do, and you're going to love this because for Polybase, the template of doing this is all the same. So in my database, I'll create a master key to encrypt my data source credentials, because you're going to see here, the database credential is based on basic authentication. So I'll need a login and a password for SQL Auth to get that Azure SQL database. Then I'm going to create a data source. A data source is going to tell me what type of data am I going after. In this particular case, it's SQL Server based because it's Azure SQL database. And then what is the name of the server? It could be various types of information here. It could be an IP address depending on that data source. Here it's going to be the fully qualified name of my Azure SQL logical server, my Azure SQL database logical server. Now this data source is metadata stored in my local database in SQL, so when I reference it, it knows how to redirect my queries to Azure. Now I create schemas for organizing my objects, so I'm going to create a schema here called Azure SQL DB, and then I'm going to go through and create what's called an external table. This is a set of metadata stored in my local database that maps columns and data types to the remote table that I'm going to query. And notice here I'll use location to say, well, what is the name of the actual database in Azure I'm going to go after? And what is the name of the table? And what is that data source, which I've defined previously, which is Azure SQL database, going to that fully qualified domain name for Azure Logical Servers. So here's a list of my columns. The columns don't have to be in the exact order as the remote table. And you can even list a subset of columns from your remote table. So you don't have to list all of them. Now the data type mapping needs to be there. And we have in our documentation about how to use specific data types from your local SQL tables to that remote SQL table. So as you look at this right now, when I query this external table, SQL Server is smart enough to know, oh, the data is really in this remote data source. I need to get it from there. Now you may be asking yourself, like, is it very smart? Do I go scan a million rows in Azure and then just bring it all back? Possibly, if necessary, depending on your query, but we support the concept of local statistics. So I'm creating statistics stored in my database, because remember, the indexes are all in the remote source. And these local stats are going to help our query processor make smart decisions. So my next step is just scanning the remote table. I'm just going to go scan. I only have one row in this particular case, so it's going to come back and bring me that one row. But if I put a where clause on top of this, depending again on those statistics, if the query processor feels it's correct, it can do a push down predicate of the where clause to the remote data source and only bring back that one row. And then what you really want to know is what's the power of doing this beyond just a single table. Now you see an example here. I'm joining the remote Azure table with local SQL Server tables and putting a union on top of it. Now imagine if we put a SQL view on top of that. People could be querying your SQL view in your local database. They have no idea where the data exists. You set up the security for authentication to get to Azure. You put security on top of your local SQL objects. And now you really abstracted the user. That is the power of data virtualization. So that's an example of Azure. What about another one? I'll look here in Azure Data Studio and using the Explorer view, and again, all these notebooks are available to you in SQL workshops. Let's take a look at Oracle. What does that look like? Oracle is going to look the same as Azure, except it's going to be a little bit specific to Oracle. Now, in my example, I show you the pre-steps for you to go create an Oracle database so that if you wanted to run this in your Oracle environment, you could do so. But notice the steps are the same. I'm going to create a master key if it doesn't exist already in my database. I'll create a new database scope credential to match my Oracle credentials. So you will need to be given Oracle access, but you're not giving access to all Oracle users, just for the users for the database scope credential here. And they're going to go through your external table to get to that Oracle data. Now, the Oracle data source in this particular case just has the keyword Oracle. This is using one of those built-in drivers I talked about. And then I need to give appropriate Oracle information to get to a host, and in this particular case, perhaps a port number for that Oracle instance that Oracle is hanging off and listening to. I'll create my schema, and then notice the external table feels the same. I've got data columns, I've got data types mapped to appropriate Oracle data types. And again, we have docs to show you how to do that. And then in the location information, this is very Oracle specific. This is Oracle instance information and schema and table information specific to Oracle. So no matter what my data source is, the location information will be specific to the type of data source. So with that information, I can create local stats. I could scan the table just like in Azure, or I could do a where clause and do a push down predicate. Now I've been asked this question, how fast is it going to be in Oracle? It will only be as fast as if I ran this query directly at Oracle itself. So provided all the indexes are there, appropriate information is set up in Oracle, this can be quite performant. And of course, the power of this is to be able to join Oracle data with local SQL data. And then if you put a view on top of this, then users would not even know that the data is all coming from both a combination of SQL Server or Oracle. And because it's a data source, I could start joining this with other data sources. Imagine you building just a schema of data sources that aren't even local SQL data. You just use SQL as a hub to go after all these different type of data sources. Let's look at one more that's interesting. How about SharePoint? I'm sure you found this is kind of crazy. Like, how would I be doing SharePoint? Well, because I have ODBC drivers for almost any data source out there, in this particular case, this data source comes from a partner of ours called CData, I'm able to go through and create a database scope credential, which is really my identity for my SharePoint system, my ID and password for SharePoint. Now notice that the data source for SharePoint puts in a driver syntax here, which is going to give you very specific information about how to get to that SharePoint server, what is the URL of the SharePoint site I'm going after, and then in this particular case, the CData partner has information about what does a schema look like for like a SharePoint list. Let's go take a look at it. Here's an external table for a SharePoint list. Column names, data types that match an actual list. I can now go after here and query a SharePoint list, just like it's a table. But I didn't directly access the database that powers SharePoint. Pretty cool technology, shows you the power of Polybase data virtualization. I showed you Azure, Oracle, SharePoint, other data sources possible for you to see in your examples. Take a look at Polybase, probably one of the hero features we've provided in SQL Server 2019. Now, if you think back to that first camera slide, we start at the far upper left-hand corner with data virtualization. And if you remember, the next two aspects of that upper quadrants were platforms and then extensibility with machine learning services. So let's talk about platforms first. In SQL 17, we started the journey with SQL Server on Linux, and we continue to make that march to make SQL Server the best database on multiple platforms. One of the things in SQL 19 we did is kind of shore up the feature set around the edge of the engine, because the engine is fully compatible. A column store index on Linux is the same as on Windows. Remember, a backup can be backed up to Windows and restored on Linux with no differences. It's all compatible, because the engine is compatible using PAL technologies. But there were some features on the edge of the engine that we needed to provide in SQL Server on Linux for some of our customers that wanted to make that move, whether it's Red Hat, Ubuntu, or SUSE that they wanted to run SQL on. And you see here that list: replication, change data capture, DTC, machine learning, Polybase, and even doing things like auto-config for tempdb files. So SQL Server on Linux continues to gain momentum and be a popular platform for customers, especially those that want to run SQL in a hybrid environment. I want to run SQL Server on Windows in some cases. I've got new applications for SQL Server on Linux, but I want to stick with one database with that T-SQL language and the tools that I know and love. Now, containers hit the same time SQL 17 hit on Linux, because containers work very, very well in a Linux environment. And we continue to do that. We continue to support containers. We shifted and moved our containers to Microsoft Container Registry to store the containers. That's to make it secure, so you have confidence there are no viruses or problems with our container image. But we still syndicate and list and publish our images through Docker Hub and through the Red Hat Container Catalog. And speaking of Red Hat, in SQL 19, we now support officially Red Hat container images, including non-root containers, so that we're fully supported in an environment like OpenShift. And then because of the fact we're running on containers, we naturally fit into the category of Kubernetes. Big data clusters was an example where we use the power of SQL containers and Kubernetes to build a scalable solution. And we continue down that journey of supporting SQL Server in Kubernetes environments. Now, I mentioned to you in the beginning about machine learning and extensibility. And so really, if you think about it, it's a little bit enhancing the developer experience. And so folks have looked at this model and said, there's no way I'm going to let anybody run a Python script on my SQL Server Enterprise computer. That's not secure and could cause a problem from a performance perspective. But take a look at the diagram here on the right-hand side and consider the following. When you're going to use SQL Server machine learning services, first of all, the feature is not installed by default, so an administrator must pick that feature to enable it. Second of all, you need to deploy a configuration option to even enable the service to be used after it's installed. The service itself, running Python, R, or even now Java, must be done through a system stored procedure, which everybody doesn't have access by default. You must grant specific usage to that system procedure. You can see the layers of security and isolation we're providing this model. Now, let's say you set up so that you can run a Python script through this model. You take the system procedure, you put your Python code in there, and you run it. Well, how do we run this on the server? In this diagram, the blue dash square is the server that SQL is running on, and the blue SQL is the SQL process. As soon as you run a Python script with that system procedure, we use something called Launchpad to, in an isolation model, run a Python process separately from your SQL Server process in a very low privileged account fashion. So already you're getting that isolation of not causing any issues with your SQL Server process. That's something called Launchpad. But you still are concerned about somebody running a Python script that's going to take over the computer. So here's what we've done. We've integrated Resource Governor with these programs. We call these satellite processes. So now you can control, through Resource Governor, the ability to throttle CPU, memory, and even affinitization for these processes. One of our customers that want to run this in production took a multi-NUMA node server, and they affinitized all their R code on one node, and then affinitized SQL on the other nodes, kind of separating that workload to still provide scalability. And then they even put rules on top of it to limit the amount of memory that those R programs would take over after doing their testing. So SQL Server Machine Learning Services is very powerful, but you can see from the architecture point of view, it could be the right move for you in a secure fashion. And then in SQL 19, what we added to this model was Java. So there could be things in Java that you know as a programmer and love that you just can't do in T-SQL. So we kind of view Java as a way to extend the T-SQL language. And we even have a platform we've built here where you're going to see other languages show up in this model. Systems Imagination, being a customer that out of the gate went right to SQL Server Machine Learning Services and I know and has loved that model because it's allowed them for their data scientists to even train and run their models on a scalable SQL server versus having to put them on workstations that may have stale data or data that's not secure. If you think back to that camera slide, at the bottom layer was performance, security, and availability, the meat and potatoes of the SQL Server engine. So let's talk a little bit about what have we done in SQL 19 with performance. We use the word intelligent performance because it's not about us just making your code fast, your applications and queries fast. We want to build in intelligent capabilities into the SQL Server engine to help make your application fast, but also give you deep insights that you have may not seen before. So before I talk about a concept of intelligent performance, make sure you understand the insights you can get from Query Store. Query Store being a great technology, it's been around since SQL 16. It's an integral part of giving you the insights when you need it. But we also upped our game at a very detailed level from a query plan debugging point of view. Especially, notice lightweight query profiling. Imagine a scenario where you can walk up to a SQL server on an actively long-running query and see where that query is in progress at the plan and operator level. So you may look at a given query that's running for a long period of time and realize it's nowhere nearing finishing and you could kill it at that point. Or you can see it's almost finished, and then go back and doing kind of later diagnostics for how long the query is running. We kind of call this insights anytime, anywhere you need it with lightweight query profiling. And here's the great thing, it's on by default. You don't have to turn on kind of special tracing mechanism to get this capability. And Banka Tao is somebody that was able to kind of use our intelligent performance capability with a concept called intelligent query processing and gain great benefit and new accelerated performance from their application. So what is intelligent query processing? Intelligent query processing is functionality built into the query processor. This isn't like a feature you check at installation time. You just install SQL 19, you go to the latest database compatibility level, and we're going to light up functionality in the query processor to make your application faster with no code changes. You may be asking yourself, like, what's an example of one of those? Well, consider table variables, a common programming pattern used by especially stored procedure developers. And there's been this issue where we've had cardinality estimation problems where we always think there's only one row in these things. So you go through this huge gyration of trying to make that stored procedure faster because the estimates for the row counts for them are not accurate. Well, when you go to SQL 19 and use the latest database compat level, we automatically can take your code, which you don't change, and make it run faster because now we're going to defer compilation of the amount of data in those table variables and then make it more accurate so that the app can run significantly faster. There's all sorts of other options and capabilities in intelligent query processing. And again, it's not a checkbox from setup. It's us taking real-world customer scenarios we've learned over time and baking into our intelligent query processing engine itself, the core of the engine, to make your apps run faster with no code changes. I got great examples in the SQL workshops for you to go take a look at, where you can go run and try and see this functionality. And the intelligence doesn't stop there, even though intelligent query processing is a great example of what we've done to make SQL Server applications faster with no code changes. You know, you probably, if you use SQL Server, seen TempDB be a problem for you over the years. And typically it comes down to concurrency from latches because of allocation pages needed for all that TempDB activity. And we've taught you how to include the right number of files over the years. In fact, we've even automated some of that in SQL Server installations. But what we found is customers go to a certain point in time with that TempDB optimization for the number of files, and they still run into some latching problems. And what happens is it's typically related to system tables that are recording information about all those TempDB drops and creates that are going on behind the scenes. So what we did in SQL 19, we used the power of in-memory OLTP, codename Hackathon, and we've implemented behind the scenes where you don't actually see that, we've implemented the system tables as Hackathon tables. Now remember, the system tables just have your metadata of your temporary tables, not your data. So the footprint's very low. But this is an alter server configuration option where you just turn this on, you restart your SQL Server, and it's even conceivable with the right number of files and with the option on, you may no longer have any latch concurrency issues in TempDB. Wouldn't that be a breath of fresh air to give you the performance you need with those heavy TempDB workloads? Now we know securing your assets with SQL Server is very important. A good majority of the functionality you see in SQL 19 from security perspective came from SQL 16. Technology is like always encrypted. But we kind of upped our game in SQL 19 with always encrypted. We now use a concept called secure enclaves, or you can use that concept if you choose to, through a virtualization process or through even technologies in newer chip technology. Now the idea being is that the unencryption of the data now happens on the server, but within what's called a secure enclave. So it still takes that separation of duties away from the database administrator. And what it does is it also lights up and makes always encrypted faster from a rich query computing point of view. Now, one of the functionalities that we thought was interesting to add to SQL 19, which also is available in Azure, is data classification. Imagine you needing a compliance trust factor in your organization that you didn't have before, like GDPR. And you need to track certain things. So what we allow you to do with data classification through our tools or through T-SQL is label your columns for what's called a sensitivity point of view. You can label which columns in my tables across my database are GDPR columns. Then, because it's stored metadata inside your SQL Server, you could then go query what are all the different columns in my database implementations that are GDPR columns. That alone right there helps you with achieving some compliance. But we go a step further. Because you've used data classification and T-SQL, SQL Audit, a feature that we've had around for several SQL releases, lights up the ability to track access to those columns. So now you can find out what columns are classified from a metadata perspective, and then use SQL Audit to audit who is trying to query columns that I've marked for, say, GDPR compliance. So that's kind of what we've done from security point in a nutshell, always encrypted. We've even enhanced some from a TDE perspective. And now we provide that new rich data classification, sensitivity, labeling, metadata, and auditing. Now, why performance and security are important, keeping your SQL Server as highly available as possible is critical to any enterprise. And in SQL Server 2019, we bring along some amazing technology I think you'll love. So kind of picture this story. One of your users comes in and runs this massive transaction of 1 billion rows, deleting 1 billion rows accidentally. And so during this time, of course, it's blocking your business and the world. And another one of your colleagues comes along and says, I got this. I'll just kill the session for that query. Then the query goes into this rollback state. We're still blocking everybody because we have to roll back that transaction. So you're really, really in trouble now from your business perspective. And another colleague comes along and says, look, I kind of read that if we just crash SQL Server, if we kill the SQL process, it'll just come back up miraculously and everything will be fine. And you do that. And in the error log, it says 1%, 2%, 3%. You have this long recovery phase. Now, during this process, you can't truncate the transaction log. And that sounds like a very, very, very bad situation. Now, I'm here to tell you today that with SQL Server 2019 and accelerated database recovery, all those problems go away. We use a technology to avoid all the challenges I list right here. And so ADR is the name for this feature. And this diagram right here looks fairly complex, but the idea being is that we're going to use versioning and techniques to make rollback very fast and undo recovery faster than you can even imagine. Now, how does this work? Because I get a lot of questions about this. Number one, it's not on by default in SQL 19. It is in Azure. And so you turn this on through a database option. And what we're going to use is a persisted version store. It's not the same versioning you have in TempDB today for isolation levels like Snapshot. It's the same type of technology, but the versions are in your database. And so rollback becomes extremely fast. It's independent of locking levels and isolation levels, so all those things still apply. And in fact, for snapshot isolation, we'll use the version in the database instead of TempDB. Undo recovery becomes so fast now. Because we have versions, we just use versions to decide what's aborted, what's not aborted, instead of having to run those compensation records through undo recovery. And because of the fact we have versions, the transaction log truncation is not tied to an active transaction, whether that be this really long delete or somebody just holding open a transaction for a long period of time. Now, you may be wondering several questions at this point, like, how much space will this take? And will it really affect performance? And so for those two questions alone, I'll defer you to a white paper that we've written, our engineering team has written. You can just look this up or use the link when you get this deck called Constant Time Recovery. And we go to all the details of performance ramifications and space ramifications for using this functionality. But take a look at it because it's very, very possible, depending on your workload, that turning this on will have a negligible impact to what you're doing in your business, but give you all these great benefits. Now, if every database uses ADR, versions in TempDB will go away because we will use, again, the versions in the database to support things like Snapshot. And then if you're wondering, does it work together with always-on availability groups? In fact, it just doesn't work with it. It makes it even better. Imagine now a failover occurs to a synced replica where we've been running redo logic the whole time. Now, in order to fail over to that replica, we just have to kick an undo, but now that happens at the snap of your fingers. In fact, this is why behind the scenes technology like hyperscale are powered, and SLAs that we have in Azure for hyperscale and for Azure in general are ADR is part of the story of giving you those SLAs. So availability groups come very fast from a failover perspective. Plus, read queries on those replicas will no longer use versions in TempDB, but use versions in the database itself. So let's take a second and take a look at a demonstration of what accelerated database recovery looks like. Now, what you have in front of you here is Azure Data Studio again, and this is a demonstration of the basics of accelerated database recovery. And again, these notebook files and all the scripts are available to you in our SQL workshops. So if you kind of look down here, this is an example of a script where I'm creating a database. I'm going to populate some data. Notice I'm going to set the recovery mode to simple. That's important to show you in a second about log truncation. And I'm going to put in, about 100,000 rows in this database table. It's not that big, but it does show you the power of what's possible with ADR. So if you scroll down here, the next cell that I'm going to run, I show the output of it, is to simply make sure the feature of an ADR is off in this database so I can show you the differences. And then go start a transaction and delete all the rows in the table. Now, if I do that, if you go take a look at the log space that is used in this particular case, again, I have an active transaction. Even though I have simple recovery on, I still have like 91% of the log that is used in this particular case. And that's because I've got an active transaction. And in fact, even if I tried to truncate the log, you'll notice here, I still have some 80% of the log that is used. And it can't be truncated because I have the active transaction. So I'm going to roll back the transaction. And notice here the rollback time takes about 11 seconds, which isn't that significant maybe, but it could be important if it's a lot more transactions to roll back. So that 11 seconds represents all that compensation record that has to occur. So we actually add additional logging to compensate for the delete to roll it back. So now, of course, if you've done your checkpoint, because it's simple recovery, after you've rolled back the transaction, you get all your log space back. Now, what does this look like when we turn on accelerated database recovery? So first of all, I'm going to go run the transaction again and run the delete, so it's an active transaction. And I'm going to look at my log space usage before and after truncate, and you see the numbers here are staggering. No longer is it 90 and almost 80%. It's down to almost like 7% after a checkpoint. That's because we're not beholden to that active transaction that is currently running. Now, if you look here at rollback, and I'll just kind of scroll the screen down here, you may ask yourself, like, how fast is rollback? So if you're watching this video, take a second and guess what you think it may be. Now, I present this in many different events and conferences, and I usually get a question like 2 or 1 or whatever. How about less than a millisecond? So if you look here, you can see here rollback happens at the snap of your fingers. This is because we just have to mark the versions aborted. We don't have to do compensation at this point. It's extremely fast to roll back a transaction. That's the basics of the power of accelerated database recovery. Now, one of the other notebooks I have is something a little bit more like advanced ADR. It's the same concept. It's the same thing, but if you go through and run this operation here, and at this point, you checkpoint and shut down or crash SQL Server without ADR, you're going to see how long recovery takes. And you can go do it again with ADR and see how faster it is. Well, let's look at an example of what the error logs look like from that example. I'll just kind of skip forward and show you, what that looks like. So without ADR, you can see here messages like this. You can see recovery. Let's just kind of scroll up a little bit here. We can see recovery of my database with these percentage numbers. Maybe you've seen this before, and it takes like an hour to recover the database. And this is actually to go do, as we're going through and run undo of the database. So if I come through and I finish all of this, in the end, it only took about a minute to go undo the recovery, but I really don't have that much data in this scenario. What again, if it's a large amount of data to undo recovery, you have no control over it, and especially, what if that was part of a failover? That would really be bad for your business's purposes of availability. Well, what about an error log with ADR for the same scenario? I'll flip over and show that. Now, in this case, there's no phases printed out. So if you look here, take a look at what recovery looks like. I've rolled back the database and I finished running recovery. It could be so fast that you don't even see the phases of recovery. You don't even know how fast the database came back and recovered. It may not always be like that, but in many, many cases, accelerated database recovery will run undo so quickly that it'll keep your business up and available as much as possible. So check out ADR, very powerful feature. To me, one of the hero features of SQL Server 2019, solving that challenge of keeping your business available even with long active transactions running in your system. So you've seen these major capabilities: data virtualization, modern platforms, machine learning services, performance, security, and availability. Let's just kind of tie together, though, the complete story of SQL 19 and talk about voice of the customer. We believe in customer feedback. And if you've looked at what we've done in SQL 19, there are many areas that we've gone and made investments on what seem like maybe small things, but to customers are extremely important. And they total up to be a pretty amazing story when it comes to user experience, whether it's changing the famous error message that has caused people so many problems over the years, or adding brand new diagnostics to help people support their workloads. And in the area of performance things that we've done behind the scenes, a lot of times we do to investigate benchmarks or customer workloads, but will benefit your application and things you don't even turn on. We just build it and bake it in to the SQL Server engine. Now, if you think about migration to SQL Server 19, we provide the tools you need. Whether it's the data migration assistant to analyze your configuration with dbcompat and let you know what possible problems could occur from a config point of view, or it's using database experimentation assistant to compare and contrast a trace of workloads between your existing SQL Server version and SQL 19. And then when you've made that migration, whether it's an in-place, restore of a backup, log shipping, replication, whatever you want to use to migrate, we have Query Tuning Assistant baked into Management Studio using the query store, so you can compare and contrast what is performance going to look like once I've migrated, when perhaps maybe I've used an older compat, I want to move to a newer database compat level. And then we've had before third-party tools, and still do, to migrate workloads from other database platforms to SQL Server. Now, speaking of database compatibility, it's our belief that customers can now certify their applications on a database compat level instead of a version of SQL Server. So imagine you moving from SQL 2008 to SQL 19, keeping your old compat level. Your application certifies on that compat level. You get to take advantage of things like accelerated database recovery. And then, using Query Tuning Assistant, you can go test what would it be like using the power of the query store to compare performance from that old compat level to the new compat level. And now you can light up functionality like intelligent query processing. So I encourage you to talk to your vendor, your application vendor, your ISV. We work directly with those vendors a lot as well to get your application certified on a database compat level. You can go to aka.ms/dbcompat to learn all the details about database compatibility could really benefit and accelerate your ability to migrate to SQL 19. Now, when it comes to SQL Server editions, we still have the tried and true Express, Web, Standard, Enterprise editions. But take a look at this chart. We have decided to enhance the lower editions of SQL Server, including, for example, in Standard Edition, you can get a big data cluster at kind of a lowered scale level, but Polybase, a single node Polybase, accelerated database recovery, and now even transparent data encryption are now all available to you in Standard Edition of SQL Server. Now, Enterprise is still Enterprise, so all the high-powered enterprise type functionality you're going to find, and in some cases involving performance, is going to show up in Enterprise Edition. But I think if you're a standard enterprise user, you've been waiting for some of this functionality to be in your edition with your workload, I think you'll love what we've done with SQL 19 Standard Edition. And of course, Developer Edition is still there for you as a free way to go out there and through dev-only data and dev-only application testing, test out your SQL Server. That could be on premises or it could even be an Azure virtual machine. We talked a lot today about SQL Server 2019, the modern data platform. We talked about data virtualization. We've talked about the challenges we're solving with modern platforms, with machine learning services. We've talked about challenges we're solving to get you faster with no app changes, make your assets secure, provide new capabilities through data classification, and then, of course, the amazing story of accelerated database recovery to keep your SQL Server highly available. Well, take a look at these resources. Of course, you can just download, and we encourage you to try that. Again, if you're using Azure, you can use a free developer edition of Azure and just pay for your compute and storage. We have free training. aka.ms SQL Workshops includes a free full-day workshop for you to use. It's open source. Fork it. Use it to your own liking. Train your team with it. And go through the entire process of learning about SQL 19 with hands-on labs and demonstrations. We've showed you notebooks, T-SQL notebooks in Azure Data Studio. Our team has built a series of example notebooks across all new capabilities with SQL 19. And then this is what you're going to love. If you love by just watching videos in little small chunks, AKMS SQL 19 Learning is some 40 plus videos that our engineering team has built across all these great new capabilities of SQL 19. And then if you're thinking about migrating, take a look at the Modernized SQL Server video where Pamela Hood and Pedro Lopes go through the process end to end of how to do pre-assessment all the way to post-migration steps to move to the latest version of SQL Server. And then, sorry for the shameless plug, but after working on the SQL Server Linux book, Pro SQL Server on Linux, I decided to write a book on SQL 19. So a lot of what you hear today in much more depth with great historical stories, interviews with the engineering team, dedicated chapters, containers and Kubernetes and big data clusters and so forth. That's all available in SQL Server 2019 Revealed. You can get that today from A-Press or Amazon. Well, I hope you enjoyed this session today, and I hope you enjoyed the rest of the event that you're participating in. And I hope you find that SQL Server 2019 is your modern data platform and can solve many of the challenges you face as a business today. Thank you for listening.